Drowsiness has been one of the leading cause of injury or fatality in bicycle accident. Therefore, in this paper, it is proposed to develop an adaptive heavy vehicle driver fatigue and alertness model based on EEG frequency band by combining signal processing algorithm and soft computing technique to estimate the driver cognitive state while driving a vehicle in virtual reality. The proposed approach is detecting drowsiness and in accessing the brain location for a passive brain-computer interface (BCI). Drowsiness has been one of the leading cause of injury or fatality in vehicle accident. Statistics on fatal or injury-causing traffic accident by Malaysian Institute of Road Safety Research (MIROS) show that the death to population ratio stands at 23.8 to 100,000 Malaysian people. 80% of fatal accidents are due to human error. Therefore, in this paper, it is proposed to develop an adaptive heavy vehicle driver fatigue and alertness model based on EEG frequency band by combining signal processing algorithm and soft computing technique such as neural fuzzy algorithm to estimate the driver cognitive state while driving a vehicle in a virtual reality based on dynamic simulator under monotonous driving environment. The proposed approach is detecting drowsiness and in assessing the brain location for a passive brain-computer interface (BCI). In this research work, it is proposed to develop an EEG driver drowsiness prediction system using suitable sensor, microcontroller, and single-board computer for a field trial. Further, the system can be utilized to alert driver and regulate in optimizing the properties of the interface system in identifying potential disaster. The proposed system alert the driver during drowsiness according to the recommendation of cognitive state and produce the fatigue index and level of alertness. The proposed system also help the driver to be more mindful and natural to avoid from deadly street accident. The development of VR-based driving simulation require broad area of knowledge and learning. Further, the placement of electrode for the EEG acquisition corresponding to the cognitive state involve different experimental observation. Based on the literature, the placement of electrode for the EEG acquisition corresponding to the cognitive state involve different experimental observation. Based on the number of channels chosen for the experiment, the EEG data acquisition method has to be chosen. Subject chosen for this study has to be from similar age group. An EEG data acquisition protocol has to be developed to capture the brain activity while the subject is drive the VR-based driving simulator. The subject has to be given unlimited access to practice the driving simulator and to be checked for health issue, smoking and alcohol consumption before the experiment. The recorded EEG signal has to be pre-processed to remove artifacts and extract features corresponding to the nature of the activity. The feature extraction algorithm has to be applied upon the EEG sample to produce different data sets. A generalized model has to be developed based on deep learning neural network to predict the drowsiness of the driver. The dataset prepared for the future extraction process has to be verified and validated for missing or outlier. Prominent feature will be extracted from the dataset using feature selection and optimization algorithm. Then the dataset generated from the EEG signal during the VR-based driving experiment have to be mapped with the corresponding drowsiness index. The developed model has to be validated against the validation dataset for accuracy. A microcontroller-based hardware setup has to be developed to demonstrate the working model of the developed prediction model.